This is going to be limits part 8, and we're going to be doing limits with polynomials. So limits part 8, limits with polynomials. And as a reminder, a polynomial is just a fancy word for a number that has more than one element in it. Kind of like x squared plus x minus 3 is a polynomial because it has more than one element. In this case, it has 3 elements. So our first example, we'll say we want to find the limit as x approaches 2 of 3x to the 4th minus 4x cubed plus 7x squared plus 5. Well, we can do limits with polynomials just how we do any kind of normal limit. So a little bit of a review from part 7 of the limit series. So this would be the same thing as 3 times 16, 2 to the 4th is 16, minus 4 times 8, plus 7 times 4 plus 5, which is 48, minus 32, plus 28, plus 5, which is 113. So that's an example of how we can do limits using polynomials, but that doesn't seem like it's really something new, but we are going to go with something new. Or, I guess what we're going to be doing with it is newer. So let's say we have the limit as x approaches 3 of 2x squared minus 3 divided by 3x plus 5. Because we can do limits with polynomials, this is the same as, let's see, we'll plug 3 in here and get 18 minus 3, so 15 on top, and in the denominator we'll get 14. So that equals 15/14. And now for the new part. That's just a little bit of a warm-up. For example 3. Let's say that we have a 0 in the denominator. So we'll have limit as x approaches 2 of x squared minus 4 divided by x minus 2. Normally when we were doing limits, we would just plug in 2 here and we would get our answer. And although something we could do is plug in a number very close to 2, one above it and one below it, and if it equaled the same number, then that would be our limit, because it would be the same approaching from the left and the right. There actually is a mathematical way to do this in a lot of cases. We can split this number at the top up, because it's a polynomial, and make it x minus 2 times x plus 2. And the denominator stays the same as x minus 2. And because we have the same thing on both sides, we can just cross this out. And we're left with x plus 2 over 1. So the limit as x approaches 2 of x squared minus 4 over x minus 2 equals this number over here. Well, equals the limit as x approaches 2 of that number. Limit as x approaches 2 of x plus 2 over 1, which is the same thing as 4. Let's go over another example. This will be a factoring one, a little bit more complicated, but still doable. Let's say we have limit as x approaches 5 of x squared minus 4x minus 5 divided by x squared minus 3x minus 10. Well, we can factor this, and in the numerator we get x minus 5 times x plus 1. In the denominator, we get x minus 5 times x plus 2. Because we have x minus 5 in the numerator and the denominator, we can cross that out, and we end up with x plus 1 divided by x plus 2. We're taking the limit as x approaches 5, so it's 5 plus 1 divided by 5 plus 2, which is equal to 6/7. So the limit as x approaches 5 of x squared minus 4x minus 5 over x squared minus 3x minus 10 equals 6/7. And we'll have one last example. This next one will be a lot harder than the others. And it's going to take some other math that hopefully you're familiar with. So, example. Let's say we have the limit as x approaches -3 of 2x cubed plus 11x squared plus 14x minus 3 divided by x plus 3. First thing we would want to do is try plugging in -3 into the denominator, but we get to divide by 0 then, and that's a problem. So the next thing we would check is, can we factor this? Well, it's going to be a little bit harder than factoring normal thing, because we're used to factoring up to x squared, but this makes it a lot harder. So we have to do something called polynomial long division. So we'll put x plus 3 on the outside, x plus 3, and we want to divide that by our numerator, which is 2x cubed plus 11x squared plus 14x minus 3. So the first thing we see is how many times does x plus 3 go into this first term here? Or how many times does x go into that first term? It happens to go in 2x squared times, so we'll put 2x squared up there, and multiply this by 2x squared. So that would be 2x cubed plus 2x squared times 3 is 6x squared. And we're going to subtract this. We'll subtract everything there. So that leaves us with 5x squared. And then the 14x and the -3 come down. Then we need to figure out how many times does x plus 3, or how many times does x really go into 5x squared. Well, let's see, that would be 5x times, so plus 5x. So it'll be 5x squared plus 5x times 3 is 15x. And if we subtract that, we get 0 there. We get, let's see, 14 minus 15 is -x minus 3. How many times does x go into -x? And it's -1 times. So we get -x minus 3. To multiply this out, we have to subtract that, which makes everything positive. And we get 0. So our remainder is 0, which is how I was hoping it would come out. So the limit as x approaches -3 of 2x cubed plus 11x squared plus 14x minus 3 over x plus 3 is equal to the limit of x approaching -3 of this multiplied by x plus 3. So that is 2x squared plus 5x minus 1 times x plus 3. And all that is still divided by x plus 3. Which that's the same on the numerator and denominator, so we can cross that out. So we just plug in negative 3 into here to get our answer. So 2 times negative 3 squared plus 5 times negative 3 minus 1. Here that would be 18 minus, that would be 2. So the limit as x approaches 3, or x approaches negative 3, of 2x cubed plus 11x squared plus 14x minus 3 divided by x plus 3 equals 2. Once again, another way to find this answer would just be to plug in numbers very close to negative 3 into your calculator and seeing what it came close to. If you plugged in negative 2.99999 and negative 3.0001, you would find a number very close to 2.